Just to understand also, take the graph that's called Meltwater Pulses. But the thing is that since you have these mile-deep, large ice shelves that cover the entirety of the North Americas and the Europe, those ones, a large part of them are essentially flash-boiled instantly.
That would be the 11.5 here is when the comets hit. That's the spike. Yeah.
Yeah, these are the two spikes, but these are the because there's two. As we said before, there are two events. But the first spike here is what this essentially shows is discharge rate in cubic kilometers into the oceans. So this is well, you're adding another ocean in an afternoon.
Jesus, yeah, that's quite a lot.
Yeah, and the primary volume of the American ice shelf, the Laurentide, empties into the Pacific through the American North, what is today the American Northwest, and it just rips the entire area, the entire land with itself, goes out straight out in the ocean. So in this case, the sea level jumps, not a meter, not 2 meters. Both these two events jumps to sea level over 40 feet.
Right, and that's a flood. Let's put it like that.
Yeah, because this doesn't happen over years. This happens perhaps over the course of a week, this entire pulse.
Jesus. Because
you have to understand that the comparative energy that is loaded into these impacts is essentially expending 4 or 5 times the entire energy in the global nuclear arsenals on the northern hemisphere. So we couldn't at our current stockpiles reproduce this event.
Right. It's even more powerful than that. Yeah, that's insane.
So that is what we are working here. So this would essentially cause global tsunamis that just goes back and forth and just drowns everything. So if you're not fast, then you're underwater.
Or if you haven't built an ark.
Yeah, or live on a mountain somewhere. Yeah, somewhere. We can have a look at that. We can look at. Let's go to the first victims of said tsunami.